Hey, we have here the integral of dx over 5 plus 3 sine x minus 2 cos x. What I want to do here is I'm going to try to solve this using Weierstrass substitution, which I have over here on the right. I did an introduction video a few days ago, and I'll provide a link in the description if you need to check that out just to see where all these values came from. Also, if you happen to solve this using a different method, just let me know in the comments. I'd be curious if someone found other ways to do this one. Okay, so let's get started. So the main thing we do with the Weierstrass substitution is this first part. We're going to make a substitution t equals tan x over 2. And of course and the thing that's so different about this is typically, like, if we were doing a u substitution, we would take part of the integral, or we do the whole denominator or something. But this is something different where we're making a substitution. We don't even have this value anywhere in the integral. But otherwise, it's just the same as any substitution where we're just getting these whatever values we need over here, and we found our dx. So we have here the values for sine and cosine, so we can make this substitution. I'll just put a 1 in the numerator, and we're going to have our 5 plus 3 sine of x being 2t over 1 plus t squared, and then we're going to have a minus 2 cos x, which is going to be 1 minus t squared over 1 plus t squared, and then we just need our dx value, which is going to be this over here. I'm just going to write it like a 2 dt in the numerator, and then we'll have a 1 plus t squared over here, and we're just going to, I smudged it. And then we're just going to use that and distribute it all the way through here. And when we distribute it, we're going to have a cancellation here and a cancellation here. So let's rewrite this thing. We're going to have 2 dt. I'm going to distribute the 5 into the 1 plus t squared. So we're going to have 5 plus 5t squared. Distributing 3 into 2t is going to be 6t. And then here we're going to have minus 2 plus 2t squared. Okay, and now all I've done here is I've just combined like terms to get 7t squared plus 6t plus 3 in the denominator. Then next what I want to do is factor out a 2/7 because we have this 2 in the numerator, and I want to get just t squared alone there. So we'll have 2/7 dt, and then we're going to have that over t squared plus 6 over 7t plus 3 over 7. Then next what I want to do here is I want to complete the square and factor this in a way where I can use the arctan formula. So let's look at that. When I do this, I can just take the half of this term here, which is going to be 3/7, and we can write this as 2 plus 3 over 7 squared. Noticing that's going to give me back 2t squared plus 6/7 t. Then we're going to have an extra term. So 3/7 squared is going to be 9 over 49, but we don't want to add that, so we'll just subtract that off so that we're essentially adding 0, and then we have our 3/7 here. 3/7, we can write that. That's the same thing as 21 over 49. That's going to allow us to combine these last two terms. Okay, so just subtracting 9 over 49 from 21 over 49, we get 12 over 49. We can actually write this as, we can write it like this, the square root squared. So writing this under the square root sign, we can actually get this into the form where we're going to have this thing is going to be, the square root of 49 is going to be 7 in the denominator, and then we could write the square root of 12 as 2 times the square root of 3. Okay, then in order to integrate this messy thing, we'll just use this formula here that we have for integrals of this type. That's going to put this into the form of an arctan. Okay, so I'm just going to kind of match this form. So we'll just keep our 2/7 out front here, and then we're going to have our 1, this is our a, and this is our u. So 1 over that's going to be the reciprocal, so we're going to have 7 over 2 square roots of 3. Okay, then we're going to have our tan inverse, our u value, which is going to be 2 plus 3 over 7. Sorry, that's a little ugly to look at. And then we have our a value, again, the reciprocal, just like this term here. So we're going to have our 7 up here, and our 2 over square root of 3. Okay, so now that we have this, we just want to see if we can clean it up a little bit. And we can cancel a 7 and a 7 here, and a 2 and a 2 here. So we just have 1 over square root of 3. I guess I'll write that as square root of 3 over 3 just to get it out of the denominator. And then here what we're going to do is distribute in this 7. So we're going to have tan inverse of 7t, and then that way 7 times 3/7 is just going to be a 3 over 2 square root of 3 plus c. Then all we need to do to finish this off is just back substitute a t. So for our final solution, we're going to have square root of 3 over 3, tan inverse 7 tan x over 2 plus 3 all over 2 square root of 3 plus c. And yes, that's a little messy, but that's kind of the way these problems end up in a lot of cases. So we'll just leave it like that. I got this problem from my quiz, Weierstrass substitution. I'll provide a link in the description. Thanks again for watching. Please like and subscribe. Have a great day.